Kia ora Year 12. Here's a small integration question from the June 2018 A-level paper. So it's some good practice, straightforward practice at integration by parts. So what we've got is this integral from pi on 6 down to 0 of x times cos of 3x dx. So the first thing we do is we look at it and we see if there's any way we can do that using just working backwards. But we can't, because we've got cos of 3x, which will have come from sine of 3x times some multiplier, but we've also got the x here. So we're going to have to do integration by parts on this one. We need to choose one of those two things to integrate and one to differentiate and leave. So if we integrate this, it's going to make things get worse and worse. That would integrate to x squared on 2. So that's probably going to be the thing that we either leave or differentiate. And this thing here is going to be the bit that we integrate, because when we integrate this, we'll end up with 1/3 of sine 3x. So integrating this is not making the problem more complex. It's keeping it about the same. But when we get to the differentiation step, the x will differentiate to 1. If this is not making any sense, that's probably because you haven't learned how to do integration by parts yet. So this is a revision video for once you do know how to do it. Right, so working through, we've got the integral we're starting with here. So the first part of my integration by parts is where I leave this function and I integrate this one. So it's x times 1/3 sine of 3x, evaluated at my limits, minus the integral when I differentiate this and again integrate this. So minus the integral of 1 times 1/3 sine 3x dx, and we have to chuck in my limits of integration. Now I could go ahead and work out what this is now, or I can just hold it in the equation until the end. That's what I'm going to do here. So this will equal x over 3 sine 3x minus, so next step is to integrate this function. So when I differentiate cosine, I get negative sine. So we're going to have cosine of 3x. I need to have a negative, and I want to end up with 1/3. So it's going to be negative 1/9 cosine of 3x. Okay, because when I differentiate cosine of 3x, I get negative 3 sine of 3x. So I need to reverse out that 3, and I need to keep in my 1/3 here. So if we put all of that together, here's what we've got. Right, so thinking quickly about the graph of the sine function and the cosine function, I know that sine of 0 is 0, sine of pi on 2 is going to give me 1, cosine of 0 is 1, cosine of pi on 2 is 0. So when I substitute all of that into my function, I get, substituting pi on 6, we get pi divided by 18 sine of pi on 2 plus 1/9 cosine of, so 3 pi on 6 is pi on 2, minus, now this bit here will become 0 because x is 0, plus 1/9 times cosine of 0. Right, that leaves me with pi on 18, because this is 1. plus 0 minus 0 minus 1/9. So my final answer here is pi on 18 minus 1/9, like that, or as the marking schedule writes it, you can take out a common factor of 1 over 18 times pi minus 2. Both of those are fine. So there you go. Now, because this is just an old exam question, I'm not teaching you how to do integration by parts. If you're watching this and you haven't done integration by parts before, you will no doubt be going, okay, what on earth is she doing up here? So you need to go find, I think in the 13 MCA playlist, the video on integration by parts, if I've done one, but I think I have. Thanks for watching. I'll do some more old questions later on.